Good morning, students. Today we will be discussing about the medicinal chemistry unit 2 drug acting on ANS, that is the cholinergic drugs. Cholinergic drugs means the drugs which release the acetylcholine, or whenever there is a problem to release the acetylcholine or the function is inhibited, then the drugs are acting. So first of all, we should know how the acetylcholine is synthesized. First, L-serine, that is the amino acid. Why it is amino acid? Because amino group and COOH group is present all over there. And with the serine decarboxylase, that means decarboxylation will be there on. So as a result, a product will be produced, and that is known as the S-adenosyl methionine. See, methyl donor, and this compound where the COOH group will be removed, and it will be known as the S-adenosyl methionine. And again, choline N methyl transferase will be acting on this. So as a result, methyl group will be transferred here. As a result, 3 methyl group is incorporated here, and the product is known as the choline. And choline acetyl transferase, that means the acetylation will be there in this hydroxy group. So acetyl CoA is as acting as a coenzyme acetyl donor. So CH3O, acetylcholine is produced. So this is the biosynthesis of acetylcholine. Now catabolism. The synthesis has been done, but we should know how the catabolism is also going on. So this is the acetylcholine ACE1234. One enzyme will be working on acetylcholinesterase, which will be broken down this compound into acetate and choline. That means CH3COOH group will be there, and the total nitrogen containing methyl group, tertiary methyl group, will be removed here. Very easy. Now cholinergic neuronal transfer mechanism. So whenever the acetylcholine is synthesized from the nerve ending, they are transporting to the different cells where the nicotinic receptor and muscarinic receptors are activated by the acetylcholine in the effector cells, and different actions are produced. So there are different type of receptors present for the cholinergic drugs. So where it is working, it is all prostaglandinic parasympathetic nerves, few postganglionic sympathetic nerves, sweat glands, some blood vessels, ganglia, both sympathetic and parasympathetic, adrenal medulla, there it is working on, skeletal muscles, CNS, that is the cortex, basal ganglia, spinal cord, and other sites. These drugs are, or acetylcholine is acting on these sites. So what are the receptors are present? Muscarinic, selective agonist muscarine, that means muscarine will help the facilitate the action. Antagonist is atropine, that means the cholinergic drugs action will be antagonized by atropine. Now coming to the nicotinic receptor, that is present in this category of the position, where selective agonist DMPP, hexamethammonium, that is the selective antagonist, and another two type of, in the both case of receptor nicotinic and muscarinic, some muscarine, oxytremoin, tremorine, and carbachol, this is the selective agonist. In nicotinic receptor, these drugs are also agonistic action, and whereas antagonists are D-cuboruridine and atropine. Next, coming to the muscarinic receptor, where it is located and where the action will be there. Now I'm not going to elaborately discuss this. So coming to the parasympathetic agents, that means that will be mimic the action of the parasympathetic neurotransmitter. So cholinergic stimulants are alkaloids, cholinesters. They are direct acting drugs. They are acting on the M receptor and nicotinic receptor, and acetylcholine is released. And some indirect acting drugs are there, reversible and irreversible. Neuromuscular end plate, skeletal muscle, and autonomic ganglion cells are activated by this drug. Now classification, there are two type of drug, directly acting cholinergic drug and cholinesters. In case of examples, cholinesters, the acetylcholine, methacholine, these are the drugs. These are the derivative of one acetylcholine. See, just acetylcholine is derivatized here with the methyl group. Bithnecol, carbachol and bithnecol, two products are there. See the structures, chlorine is present and all the products are same like this, where amine group is incorporated here. Next, cholinomimetic alkaloids, pilocarpine and muscarine. These are the important natural category of the drug, where they can also having action like the cholinergic drugs. Now coming to the indirectly acting cholinergic drugs, they are classified into two categories: reversible cholinesterase inhibitor. That means the cholinesterase enzyme will be inhibited, but the action will be reversible. That means whenever the inhibitors are removed, the action is reversed. So this case, physostigmine, that is one of the alkaloid, 2 nitrogen containing, and neostigmine bromide. These are the reversible category of the drug. Next, neostigmine bromide, pyridostigmine, hydrophonium. These are the all bromide and chloride containing drug. Now, ammonium chloride, that is not so important. Now coming to the irreversible cholinesterase inhibitor, that means if these drugs are applied, the cholinesterase enzyme is completely inhibited and it is irreversible. That means though the drug is removed, the action is not reversed. So pralidoxime chloride and ictharpate iodide, whereas pralidoxime is important category. Classification. Then another category, malathion, isofluropate, parathion. These are the another category of the drug. Now conformations are there, different conformation. That means if we see through a ball and stick model, we can see this structure, geometric isomerism, synclinical, synperiplanar, anticlinical, antiperiplanar, like this. Activate N receptor, that means nicotinic receptors are activated by this drug. Activate M receptor. Now coming to the SAR of sympathomimetic drug. So this choline or ethylene bridge is activated and the ester function is group here and the quaternary ammonium group. So modification of the quaternary ammonium group, that means if this quaternary ammonium group is modified, the quaternary ammonium group is essential for the intrinsic activity. So that means this quaternary ammonium group is very essential for the action of drug. The trimethyl ammonium group is the optimum functional moiety for the activity. This 3-methyl group is present, that is also very important. Placement of primary, secondary or tertiary amines leads to decrease in activity. That means if this amine group is removed, then the activity will be decreased. Now modification of the acyloxy group. This acyloxy group is present. So the ester group of acetylcholine contributes to the binding of the compound to the muscarinic receptor. Now replacement of the methyl group by the ethyl or large alkyl group produces inactive compound. That means if this methyl group is replaced by ethyl or large alkyl group, then the product will be inactivated. Esters of aromatic or higher molecular weight acid processes cholinergic antagonist activity. That means if the compound is esterified with aromatic or higher molecular weight, that means the drug will be cholinergic antagonistic property. SR parasympathomimetic agents modify ethylene bridge. This ethylene bridge, if this ethylene bridge, the methyl ester is rapidly hydrolyzed by cholinesterase to choline and acetic acid. That means in this portion, acetylcholinesterase esterase is working on. So the methyl ester is rapidly hydrolyzed. To reduce susceptibility to hydrolysis, the carbamate esters of choline, carbachol were synthesized and were found to be more stable than the carboxylate esters. Modification of the ethylene bridge. So placement of alpha substitution results in the reduction of both nicotinic and muscarinic activity. That means if the alpha carbon is substituted, then nicotinic and muscarinic activity will be diminished. Incorporation of the beta substitution leads to the reduction of nicotinic activity to greater extent. That means if the beta group carbon hydrogen is substituted, then reduction of the nicotinic activity going on. Replacement of the ester group COOCr with ether or ketone produces chemically stable and potent compound. So up to this I'm completing here. Now we will be going to direct acting agents tomorrow. Thank you everyone.